Hello and welcome back to my channel. Today we're going to be talking about representing functions as power series, and we're going to be talking about it in a couple different ways, starting with differentiating. So consider the function f of x is equal to sine of x. We know that the derivative of sine is cosine. Consider the power series for the function sine of x centered at 0. So for sine of x, sine is all of our odd terms. So we have x, we have minus x cubed over 3 factorial, plus x to the 5th over 5 factorial, minus x to the 7th over 7 factorial, and that goes on. And we want our general term. So we have negative 1 to the n times x to the 2n plus 1 to make it odd, divided by 2n plus 1 factorial. And that goes on forever. So what we're going to do is we are going to look at the derivatives of each of these terms and then see what happens. So if I take the derivative of x, 1x to the first, we get 1. If I take the derivative of x cubed, 3 factorial is a constant, so I don't have to worry about it. We get 3x squared divided by 3 factorial. Derivative of x to the 5th, we get 5x to the 4th over 5 factorial. Minus 7x to the 6th over 7 factorial. And that continues on until the general term. So our general term, we're going to be taking the derivative of things with respect to x. So negative 1 to the n, 2n plus 1 factorial, those are both constants, so those are going to stay. And then we take the derivative of x to the 2n plus 1. So we multiply by 2n plus 1, and then take 1 away from our exponent. Well, our exponent is going to be x to the 2n plus 1 minus 1, so plus 1 and minus 1 go away, so we get the 2n power. And that goes on forever. So what we're going to do now is we're going to kind of simplify what we have here. 1 doesn't change. I have 3 on top, I have 3 factorial, reminding ourselves that 3 factorial is 3 times 2 times 1. If I have a 3 on top and 3 factorial, those 3's are going to cancel out, so we can divide a 3 from this term. This gives us x squared. If I divide by 3, that 3 factorial is going to become 2 factorial. We have a 5 on top, a 5 factorial on bottom, so we have 5 times 4 times 3 times 2 times 1, so those 5's can cancel each other out. That still leaves us with all the other pieces there, so we get 4 factorial. I have 7 on top, 7 factorial on bottom. So I have 7 is going to divide with 7, but I still have 6 times 5 times 4 times 3 times 2 times 1. So this is going to be 6 factorial. And that's going to happen all the way to our general term. So in our general term, negative 1 to the n, that stays. There's nothing that can cancel out with it. But we have 2n plus 1, and we're dividing 2n plus 1 factorial. 2n plus 1 is a part of 2n plus 1 factorial, so I know I can get rid of that first term, just like all the other ones. So what we are going to really be dividing by is taking away that one term, so we get 2n factorial, and we keep x to the 2n power. So if we look at what we had when we started out with and what our derivative is, we can see that all of our exponents went down by 1, all of our factorials went down by 1, and we started out with 1 and x to the 0 power instead of x to the first. This right here is our power series for cosine, and because it's going to an infinite amount, we know that this is the exact same thing as cosine. So the derivative of sine's power series is cosine's power series. So we're still getting those same derivatives that we would have gotten normally. So let's look at this function. Let h of x be the function represented by the series, the summation from n equals 1 to infinity of x to the n power divided by n squared. This right here is going to be really important for us because it has n. This is going to be our general term. So that function that we are given is our general term. A says, write the first three terms of the series for h of x. So we want to make sure that we only write the first three terms. We can write them out and then simplify if we need to, or we can just simplify as we go. I'm going to write them out and simplify just for this case. So because this is only the first three terms, where you're going to use the approximate symbol. So h of x is approximately, we want the first three terms. So our first term is going to start at n equals 1. So I have x to the first divided by n squared. N is 1, so I have 1 squared. And a summation is addition, so we add our next term. So n is now 2, so I have x squared divided by 2 squared. And then I'm going to have my n equals 3, x cubed divided by 3 squared. So looking at this, I have 3 terms now. I have 3 separate things that I'm adding together that are non-zero. So all I'm going to do is simplify what I have. So x to the first divided by 1 squared. 1 squared is 1. X to the first is 6. So I have x plus x squared divided by 4 plus x cubed divided by 3. Okay. The next question is, write the first 3 terms and the general term for our series h prime of x. So as a reminder, this right here, this piece, so not the summation part, but this is our general term for h of x. So we want to find the derivative h prime, and we're going to write the first 3 terms and the general term. So this time, what we're going to do is we're going to figure out what h prime of x would equal, and then we're going to go from there. So we already did the work to find h of x for the first 3 terms, so we're just going to use those first 3 terms to help us out. So the first term we found for h of x was x, so we're going to take the derivative of that, gives us 1. We're going to take the derivative of x squared over 4, so we have 2x divided by 4. We have x cubed over 3, the derivative of that, we're going to have 3x squared divided by, okay, so I made a mistake over here, so this shouldn't be a 3, 3 squared is 9. So we're going to have it divided by 9 right here. Okay, so those are the first 3 terms we care about, but we also want the general term, so I'm going to act like we have a derivative here like normal, and we need to take the derivative of the general term. So we have x to the n divided by n squared. Divided by n squared is a constant, so I know I'm going to have this in the denominator. X to the n is just power rule, so I have n x to the n minus 1. And that's going to go on forever if we have h prime. Okay, I'm going to simplify it, and then we're going to write out what our 3 terms is and our general term is. So we have 1, that doesn't change. 2x divided by 4, 2 and 4 cancel each other out a little bit, so 2/4 is the same thing as 1/2, so I have x over 2. We have 3x squared divided by 9. 3 divided by 9 is going to be 1/3. And that goes on forever. Okay, so I have nx to the n minus 1 divided by n squared. I have an n on top and n squared on bottom, so those are going to divide out to get just n on the bottom. Okay, so now here's where we want to be specific, because how I have it written right now, there are more than the first 3 terms. So all we're going to do is make it very clear which ones are the first 3 terms and which one is the general term. So I'm going to write first 3 terms. Our first 3 terms are 1 plus x over 2 plus x squared over 3. On the other hand, our general term is this x to the n minus 1 over n. Okay. So when we're taking derivatives, we're going to use all the same rules that we would have used before. We just need to know what that series is first, so that way it becomes a lot easier. So we're not taking the derivative of a series as it looks originally. We want to take the derivative of each term to then take the derivative of the general term.